Kate, time to go. Lemonade acquired. I swear I opened it. What? I guess I didn't. Oh no, because I did it wrong. Oh no. There we go. Okay, no more debugging. We're on to fundamental data types. Nice. What am I gonna learn? What am I gonna learn soon? Voids. Oh, I can get size of now. Signed. I don't know the difference. Ooh. Ooh. Oh. Ooh. Okay, nice. I learned some cool stuff soon. Okay. This is the start of the fundamental data type. Okay. Bits, bytes, and memory addressing. Variables are names, yes, are identifiers for a piece of memory. Is an identifier and is instantiated, meaning is given a piece of memory which has a garbage value which is overwritten whenever it is initialized, assuming you're not default initializing. And you can go and reference them using the identifier instead of having to fucking type in ampersand. Don't need to do all that. Alright. Oh, glasses. That is why the text looks a little bit funky. Not LASIKing yet. No money yet. But once I have 80 grand in the bank, I will get LASIK. So see me in 2 or 3 years. Assuming that, well, that would assume that I get, well, I'll probably be there in 2 or 3 years. Even though I don't make shit now, I make 50 grand. Alright. I'll be good once rent's cheaper, holy. Random access, okay, here we go. Talked about the values. Variables are names for a piece of memory that can be used to store information. Yep. Well, you should say variables are names for pieces of memory that can be used to store information. A variable is a name for a piece of memory. Meters of random access memory. Yeah, it's all these pieces. It's assigned in the beginning. We don't know exactly where it is. Piece of memory set assigned. We don't necessarily know where. We could probably specifically set it. But apparently we usually don't. That's why it's called random access. Smallest unit of memory is called a binary digit, a bit. It's going to hold a value of 0, 1, true, false. Light switch, on, off. 0, 1, no in between. Random segment, 0, 1, 0, blah, blah, blah. Okay. Organized into sequential units called memory addresses. Addresses. Similar to how street address, yep, memory address allows us to get there. Find where the memory is. Each bit does not get its own unique. It's because the number of addresses is limited and the need to access data bit by bit is rare. Instead, each address has 8 bits. At least the modern standard. A byte is a group of bits that are operated as a unit. We work with bite-sized chunks of data. Okay. Okay. Wonder if that's the number in the array of memory addresses in little slots. Is this the... Okay, so there's 1. Oh, wait. 9. And I'm out. It's like 60 or something. Bytes of different sizes, 1 to 48. Wow. Modern is 8, so it's fine. We assume 8. Okay. Just a sequence of bits. We use a data type to tell the compiler how to interpret the contents of the memory in some meaningful way. You can do this, you can't do that. Do this automatically, don't do that. One data type, the integer. When we declare the variable as an integer, we're saying the piece of memory that this variable uses. Well, the values within the piece of memory is going to be interpreted as an integer. Okay. When you give an object a value, the compiler and CPU take care of computing the value. Okay. Meaning I assign it 65, the compiler then converts this to that, the bit version, the binary, and then once we get that address and try and get the values at that address and do stuff with them, we then it compiles it, it converts it back. Compiler and CPU do all the converting, nice. Pick a data type for the object that best matches its use. Fundamental data types. Oh, nice. Okay. Okay, so there's a void, there's null pointer, there are integers. An integral? Oh, there are different types of integrals. Okay, I don't know why they're called integral. Is it just because they're important? Like the primary? I don't know. Booleans, they're true or falses, they're characters, which are text. Integers, which are just numbers that are non-zero. Or non-floating point, whatever you want to say. Just numbers without a fractional piece. Oh, yeah, I guess you could say there's whole numbers. Oh, yeah, that would include zero. Floating point, yep. Anything fractional. So rational versus irrational sounds like. Okay. An integer is a number with no decimal or fractional part, including negative, positive, and zero. The term integral has several different meanings, but in the context, it is used to mean like an integer. So there are different types. Okay. Trying to not say or think any of the things that I already know. I'm trying to just absorb all of this. Okay, like an integer. Standard types are shorts, ints, longs, and long longs. Interesting. Looks like short int, long int. Signed and unsigned. The integral types are bool, characters, and integers. Excuse me. All integral types, so again, characters, booleans, integers, are stored in their memory as integer values. So all of these, true or false, characters, and integers. So true or false sounds like 0 and 1. 0, 1. But only the standard integer will display as an integer value when output. So if we output a character or a bool, they don't output as integer values. Okay. So they're all stored there. So there's a little piece of memory. It's got some bytes in it.
and it says, hey, this is a Boolean. We've given it an identifier, and it links this identifier to, or gives this identifier attribute thing, quality, characteristic, definition, description of this little storage bucket. And says, hey, there's a value in here. This value is 01001100, whatever the hell that is. Like 60 something ish. Maybe, I don't know. 01 sounds like max is 128, maybe. Looks like it's 60 something, so maybe it's probably 70ish, 71 or 69 maybe. Nice. So you see this binary information in here, Mr. Compiler. Treat these values when you're outputting them as the name. In this case, it's a Boolean, so 0 and 1. This time it's a character, so A, B, C, D, E, F, G. This time it's an integer, so actually return it as the number that it already is. Okay. The integral types are all stored, but only the standard integer types will display as integer values. We'll discuss the Boolean chars later. C++ standard explicitly notes integer type, synonym for integral type. Makes sense, because if I said integer types, somebody might think I mean Boolean characters and integers. Somebody else might think I mean literally just the integers. So how are we going to use it here? Yeah, it's more often shorthand for standard integer types. So there are integers, Booleans, characters. These are all integral. And then there are other things. Void, null pointer, floating point. It seems like everything else is kind of a combination of these somehow. Or a lot of things are. Like floats are used in some cases. Okay. Oh, true, yeah, because there are non-fundamental types. Oh, God. Okay. Integral types only includes fundamental types, because these are fundamental data types. Non-fundamental data, and it doesn't even include all of the fundamentals. Excuse me. Enum and enum class are not integral types, even when stored as an integer. Okay. Other sets of types. Okay. Oh, wow. Compound data types. Structs, maybe. Okay. So there are predefined, and then there are non-predefined, but pre-written, includable. Template library, STL. Standard library. I guess it's not even STL, it's just a standard library is what you call it. And template library is probably like a sub-library. Okay. Oh, okay, linking meaning just properly using them sounds like. Like, standards character output. STD : C out. C out. Yeah, built in versus Strowstrup. Oh, okay, because the other ones, because compound are also technically built in. Okay, so no built in. All right. Okay. Man, allergies, holy shit. A data type to handle strings. Hmm. Oh, damn. Okay. Underscore T. Type. Yeah, it's cool. Char underscore type. Int underscore type. Underscore T. It's probably type. Okay. Void. No type. Incomplete type. Oh. So I wonder if there are types later on that I can declare but then actually define later. Meaning either I change the type or the type that has been declared. The type has been declared but not defined. So I could declare a type maybe but not define it and then set that type but then later do something with it? Maybe? I don't know why I would use it yet. I don't know a use case just yet. So what does it then do? I mean, it has to store the information somewhere. Because there's something that's saying this function doesn't return shit. Which means it returns something. Sounds like. Something in order for the code that called the function to say, okay, don't need it. Or maybe void is like a signal. It's a signal to the function to not return something because it doesn't know how much memory, so it doesn't. It just sees it as a question mark and then proceeds with whatever that means. Not returning something. It's intentionally incomplete since it represents the lack of a type and can't be defined. Okay. Our first example of an incomplete type. Yeah, because we're defining it, we're declaring it, we're also defining it, and also value initializing it. Or sorry, default initializing it. But it doesn't work because it's not a complete type. Too many words. Yep. Non-value returning functions, we know that. Yep. Compiler error because void is not returning. Yep. Void means it shouldn't be returning something, so void tells it something. So it sees that it has an incomplete type, specifically void, which means don't return something. So if it does return something, it compile errors. Deprecated. Oh, so it's not. Oh, nice, because they don't actually need to put void now. That's nice. No more int main void. Woo! Nice. Oh. Oh. Okay. A void pointer. Wonder how that's different from a null pointer. I mean, what? Yep. I'm picturing something like Winderstat. Winderstat is apparently a program that indexes, or at least it basically, what sounds like it it looks and appears to function like it scans the whole memory of your computer, your entire storage, not your random access memory, but your actual static memory, your hard drives and solid state drives, and splits it up into a bunch of chunks. It sounds like memory is actually kind of like that, where it's not all like a cubby you get from IKEA where they're all 4x4 freaking foot by foot squares. Instead, it's like, oh, this one's 8 inches by 8 inches. Oh, this one's 4x8. Oh, this one's 12 by 12. It's not all the cubby holes are not all even size. The mailboxes the mailman goes to are not all the same. Bite-sized units, so they all have subunits of bytes. But nobody said that they had to have the same amount of bytes. Most objects take up more. A single object may use more. Okay. So the type determines the size of the mailbox. So we say a type, and then the compiler says, oh, here, I have that one. I have one that's that size. This one's right. That's the right size for you, buddy. You need a character? Oh, it's that size. You need an integer? Oh, it's that size. You need a void? Oh, you need a float? It's that size. Cool, man. Thanks. Amount of memory used is based on the type. We access them through variable names and not the memory addresses themselves. hides how many bytes it takes. That's where size of comes. Ooh, X is this many bytes. Let me go and find one where X is and retrieve this many bytes of info. And we'll compile that shit back. Or convert it back to source. Or non-machine language code. The more memory, the more information it can hold. Oh, so each of these are bits. Two bits. 4 bits. Oh wait, hold on, 2 bits? 3 bits? What? What are you talking about? Oh, here we go. Single bit, that. 0 or 1. 2 bits can have 0, 0, they can be 0, 1, they can be 1, 0, they can be 1, 1. 3 bits can have 8, keeps doubling, it's just powers of 2. 1, 1, 1, 1, 1. Oh, okay. 0, 1, 2, 3, 4, 5, 6, 7. 7, 0, so 8. The individual ones. Object with n bits, because each one is a power of 2, so. Yep. Hmm. Ah. Yep, more bits, more freaking binaries, buddy. More zeros and ones. Oh, now you doubled the answer. Oh, no, it's not. Okay. Doubled again. Yep. Oof. Believable. Optimizing too much. Negligible. Yeah, that's right. Better, more maintainable code. Sounds good, buddy. So I've been trying to operate, at least in game dev too. Huh. Is the character 4? Is an int 8? Is a boolean 2? I don't know. Hmm. Excuse me. Huh. Oh, because yeah, but characters were integral types, but they were. Oh yeah, well, characters were. Are you sure, buddy? Oh, too far. Well, here, I mean, because these were all integral types, I thought. I know, character, Boolean integral, I guess. So I guess the exact size of any of the types. Huh. Okay.